So hey everyone, I'm Amir, CEO and founder of Baseshift. So we've all been there. We're DevOps, someone comes to the DevOps and says, hey, you got a sec? We need an environment. A salesman might come along and say, we need a demo. Tomorrow we have a prospect, or next week we have a conference. Major headache. But okay, we say we'll take some of the Docker images, we'll throw together a Docker Compose file, we'll put together a Helm chart, shove all the services in, and we'll have an environment. But then there's the database. There's always the database. Not fun. Why is there a problem with database copies? Well, it's never just a database copy. The first problem is distribution. You can't just have a copy, you have to move it. You might have a production region or a production account, but sales and R&D work in a different region or a different account. So now you have to start moving data around. Second, you can't just take data out of production and give it to people. You have no choice but to apply masking policies. So you have to run scripts and you have to write extra code. And even if you do all of that, now you have a problem with speed. It takes a long time to copy databases out of production and into R&D or demo environments. And now developers are writing code with AI. If you're writing code with AI, raise your hand. If you write code with AI and the AI goes crazy and doesn't do what you tell it to do, raise your hand. And now the developers want to connect this to the database. Sounds scary. We've seen what happens when you let the AI touch the database. It'll drop the whole thing, it'll remove entire files, wipe out your hard disk or your home directory. And this is why we built Baseshift. Baseshift is an end-to-end, all batteries included solution for getting data out of production and into people's hands. Baseshift will copy data, mask data, subset data, snapshot the data, and then make it available to everyone inside the business in a variety of methods. Additionally, when you run copies over Baseshift, we provide methods to manage and audit how they're used. Let's take a look at how Baseshift works. Baseshift provides two components to put into your environment. All of your data remains in your cloud and in your VPC. There's two main components. One is a replication server, the other is a proxy. On the replication server, we start up a database. This is the same database you would download off the internet. Postgres, MySQL, Maria, Mongo. The database is started up initially empty. The Baseshift server will then go to the original database, your RDS, your GCP SQL server, and start copying data. Here is where Baseshift is very different from everything else. Most solutions first copy data, then anonymize. That's a major headache. Baseshift does the invert. We copy data through our proxy, which opens up the packets and modifies the data in transit. By the time it's loaded into the instance in our server, it's already anonymized. This means Baseshift is essentially a masked replica, like a read replica, but anonymized. We take this replica and create snapshots. Now, our snapshots are different from everything else you've ever seen. It is not EBS, it is not EFS, it is not RDS snapshots. Our snapshots are just files, literally a folder with binary files. You can take this folder, you can zip it, you can tar-gz it, you can put it in the cloud in S3, you can move it around with a USB drive. But we make this very easy for you by wrapping everything as a Docker image. So the output of our server can be a Docker image, which we push to ECR or to Artifactory or to Docker Registry Docker Hub. Additionally, our server can run server clones. You can just send us a command by CLI through the UI, which you'll see in a second, or MCP or REST. You can run dozens of copies of your database in Baseshift simultaneously. Let's take a quick look at how this works. Say you have a 1 terabyte database in production. Maybe it's in California. You now need to run a copy of it somewhere else. maybe on the East Coast, maybe in Europe. So you create a copy with Baseshift, which generates a snapshot. This snapshot is compressed, so say about 1/3 of the size of the original database. The thing is, on the next day, you want a new snapshot. You probably don't want to download the entire terabyte again. And that's where Baseshift is special. Baseshift detects the changes from one day to the next and can encode them too as a delta snapshot. On top of these snapshots, you can run clones. You can run dozens or hundreds of clones at will, where the clones are completely isolated. One developer does not see the changes of another's database. They share the snapshot between them, but the clones are isolated. The clones take up space proportional to the amount of changes every developer makes on their clone. Let's take a look at a demo. So this is Baseshift. In Baseshift, we create objects called dubs. A dub is a combination of a source database, a masking policy, a subset policy, and a snapshot schedule. We've went ahead and created one dub here for a database that's just 1.2 gigs. Now that we've created this dub, we can launch clones. We can launch, as I said, a clone on the server. Again, this is a server running in your cloud. And you can just click to launch a clone. And you can keep running more clones as much as you want. When I pressed the button, the clone was launched. Now again, this is one server running multiple clones in the same place. It's not starting up an RDS. It's not starting up an instance. Additionally, you can get a clone by getting the Docker image. That's what get local copy does. It's a set of instructions that you can authenticate against the Docker registry, pull a Docker image, and then run it. You can run it locally on your computer, or you can connect it to your Kubernetes. Now remember we started talking about AI and how AI can go off the reservation and start deleting stuff or not doing what you asked it to do. So let's take a look at how we solve that problem. Before I start the demo, here is an example database. This is called the Acme HR database, created by Oracle about 30 years ago for SQL training. This depicts 6 tables that would be a relatively simple HR system. Now let's say we want to modify the tables, or specifically, we want the AI to modify the tables. Our request is to take the titles column in the titles table and to normalize it. We want a table of unique titles. What will happen is that the AI will run into an error. This happens with real complex systems. An edge case in production causes a migration to succeed in development and test, but fail in production. Let's see what happens when the AI uses Baseshift. This is Windsurf. We've created a fake app in Python Django over the Acme HR database. We've requested from the AI to modify the database such that it can normalize the titles table. Because it takes time to run this, we've run it in advance. What you can see here is that the AI analyzes the code and then thinks, oh, you know what I should do? I should start up a clone. And that's what it does. Starting up a clone in Baseshift, as you've seen, takes just a second. Now the AI will analyze the clone, run queries, and then realize it needs to start up a migration. It looks at the titles column and it says, okay, here's 2 variations of the same title. So it generates a migration and then it tries to run the migration. But the migration fails. This is what would happen in the real world. In the real world, a developer writes some code, the test passes, on the local machine it passes, but when the code reaches production, we hit an error because there's an edge case in production that doesn't exist anywhere else. The AI realizes this all by itself because of Baseshift, realizes there's a problem with the data, stops the first clone, starts a new clone, again, in seconds, and then fixes the migration in order to run it successfully. At this point, it verifies, and it says, great, I'm done. But our problems don't end there. So the AI realized that there's a problem, stopped the clone, started the clone, fixed the migration, no problem. So now we create a merge request, right? We think we're done. So what happens when we push a merge request into GitHub? Well, the developer is not going to read all of the AI code, right? Nobody reads all of the AI code. That's crazy. And even if the developer reads the AI code, it's hard to expect from them to understand what the database is going to be affected by. It's just too many hops to expect from a normal person. So Baseshift adds a guard. It adds a PR gate to analyze the change and understand how it impacts production. And it gives the developer or the reviewer two key pieces of information. Piece number one, what are the facts? What did the AI do, or what did the developer do to the database? In this case, we can see it created a new table, and it modified one table to add a foreign key. But that's not all. What could happen is that the migration succeeds and everything is fine, and the developer is like, okay, sure, change those tables, but the developer, and definitely the AI, don't know that something is running in production that will be affected. And if you've ever seen this happen, this can be a terrible night or a terrible weekend. What Baseshift will do is analyze how the PR affects the database by recording the queries sent to the clone while it was being written, while the migration was being written. We then compare these queries to what we know about production and produce a risk mitigation report. And we'll tell you, here's a query that will be modified, but after this modification, in production, it will no longer use an index, which is kind of a problem. More importantly, the migration itself will lock a table, preventing transactions while it runs. This is pretty scary, and the developer needs to know about it. So that's how Baseshift helps you mitigate and prevent issues in production. It also lets you create sandboxes for developers, for AI, and for testing purposes. So that's about it for today. Thank you for listening. If you want to join the beta, you're welcome to fill out baseshift.com's waitlist or just come talk to me. Thank you.